I'm back streaming again. It's been close to a month for me now since I've been doing this, so might be a little fresh, a little rusty, but yeah, I'm excited to get back at it. Let me see here. Let me just make sure things are actually working. I think that they are. And if that is the case, then I should just get to hop into it right away. Now, let me just check that it is indeed true that we're live here. I'm going to do that on the down low for a minute here. Starting smooth. Let's see here. Okay, let's go to my channel and see if it's actually broadcasting. It is indeed. It's me, and that's me over there. Infinite loop. Let's get out of there. Let's get rid of that. Okay, so this is nice and easy because there's currently no one watching, which it's not something I care to see directly, but I've got a weird glitch on my manager side here, so I'm just gonna pop a little look at that. My manager tells me to hang in there. Well, actually, let's have a look here. I've got the treacherous problem where we're kind of using the full capacity. There we go. Okay, things are looking fine-ish now. So, actually, I did I think this will work. I tried to install. I signed into Nightbot to see if I could set up some chat shortcut things. Chat commands is what they're called. And I'm just unrecognized command. Okay, so it might be typing with the wrong keyboard here. I suppose that this doesn't work yet. Oh man, well, I'm gonna have to try a little harder than that, I guess, which is fine. Yeah, actually, I mean, while I'm here starting and fumbling around anyway, I may as well see what I can get working. Might be related to Okay, well, let me try this. May as well figure it out live. Let's see if that works. Okay. All right, so now this is the riveting portion of just figuring things out. That's fine with me. That is fine with me. Unrecognized command. Yeah, okay. I wonder if okay, I see. Okay, so Nightbot's responding. I just have to, let me try one final thing. Let's edit this. Let's have a look here. Using the wrong keyboard once again. Will I learn? One day. One day I might learn. Okay, let's do that, and let's do this. Let me see. Okay, so I saved those. I wonder if they will work right away. Hey, cool. This is going to be a problem. Let's edit this. Okay. Just spamming my own links, testing the chat out. Lovely. Okay, so that's a good start. So I've got Nightbot working on my behalf here with a few basic codes. That should be okay. Pretty happy with that for now. So I got links, and I've got a little support thing. It can support me through Patreon. There's one more little error here. Try that one more time. Maybe I went a little too quick there. Oh, I didn't click save, I suppose. Okay. Let me just solve this problem a different way. There. Okay, last little bit of chat spam for now. Okay, looks like it'll work. Hopefully those are the correct links. I think they should be fine. Over time I should be able to add to the commands list, because this is not too hard actually, which is kind of fun. Alright, so that is good sweet happiness for me. Let me go ahead and close that. Let's go on down to, I still have to work on a little bit of channel art and stuff like that, but it's pretty good for now. So oh, one thing, if you're tuning in now and viewing, I wonder if there's any viewers. Let me have a look here. If you're tuned in now and you want to talk and ask questions in the chat, you go right ahead. Don't worry about interrupting me. If I'm busy, I might not respond, but never reason not to engage in the chat. I find it really enjoyable to go and talk from time to time with people. Oh, I forgot to start a timer for myself here. So if you're there and you ever want to talk, you go right ahead and talk in the chat. It's no problem with me. In my apartment building, they are testing the these things, the fire alarms, and they've been going off this morning intermittently. So I don't know. I think they won't be going off. I hope they won't be going off anymore, but apologies if they do. I'll have to hover my finger over the mute button, and maybe if it's very, very disruptive, I might have to cut the stream short. But I think we'll be okay, so that's just a little bit of a warning about the fire alarms. Nothing's going wrong. Should be fine. Gotta close my curtain for a second. Reduce the glare on my face a little bit. My top of my head kind of has a little shine to it. That is okay. Right, so on that note, it's been about almost a month now since I've been streaming, and there's a few reasons for that related to travel, just wanting to take a bit of time off, organizing a few things for my career, and job prospects and stuff like that. But I am ready to get back to my programming again, and what I'm doing is same as usual. I'm using Clojure code to create CAD tools. So today I'm just getting myself back into the mindset, so I don't think I have much in the way of critical work to do. I mean, there's always critical work. I guess I should say I just don't have much of a plan in place right now. But I have kind of come up with a loose restructuring of how I think through this, my sets of code. And so what basically is happening here is a split of code into some libraries that kind of make sense on their own. So I've got here okay. The basic idea is I have these three things here: Forge library, Stylo library, and ASDF. And I think that ASDF probably needs a rename, but the idea is pretty straightforward. I am going to, let me see, just one second here. Nope, we're good. The whole idea is this. The end goal is to make CAD tools to help me do more and more engineering and design work. To do that nicely, I've been working on this Stylo library quite a bit, which lets me create documents that have SVG kind of right in there, using HTML and SVG. I've been messing around in a Scratch sort of app called ASDF. It uses Reagent, which is a Clojure library, basically a wrapper over React, and I've been using that, which is actually running here in this terminal here, to make little tests Hey, Emerson, how are you? Why didn't I stream for so long? That's a fair question. So actually, I at the start of the month, I was. You're doing well? Glad to hear it. I'm doing quite well too. I'm actually excited to be back streaming again. The reason I was gone for so long, at the start of the month, I was traveling into America, to California, to visit with some friends there. A friend of mine is getting married, so it's been a while since we've seen each other in person, so I went over there, and because there's a a bit of a COVID-related global struggle going on, to put it mildly, between Canada and the States, you're allowed to travel into the States, but you have to fly there. And when you come back into Canada, you have to do what's called self-isolation for 2 weeks. And the reason for that is to just greatly reduce the risk of spreading the virus. You know, if I come back and I'm asymptomatic and I'm going out and about and talking with everyone, I might transmit the virus. So Canada requires you to self-isolate for 2 weeks, and I theoretically could have been streaming during that time, but I decided to not, to give myself just a little bit of a breather again. I think it's important to take breaks, and it was a reasonable opportunity for me to do so. Maybe it was too long of a break, I don't know, but I feel really good and refreshed and healthy, and I'm excited to get back into it again. Hey Zertroniker, how are you? I hope you're doing well. I was just explaining to Emerson why I was not streaming for a little bit of time there. The first week of the month for sure I couldn't have, because I was traveling anyway, and the second 2 weeks I was self-isolating and just used it to take a step back. But I'm back here, I'm back streaming again, and I'm excited about it. So yeah, I hope everyone's doing okay. I'm glad you're tuned in. That's really I was a little honestly nervous that you start to build an audience, and if you do take a bit of a break, I didn't know how people would respond, if it would be as if if no one would tune in again. So it is comforting to be able to engage with you in the chat already. I really appreciate that. So yeah, I'm glad to be back. At the same time, I'm sure it's not like the world stops turning if I stop streaming, so everyone's free to do as they please. They'll never stop watching me? Oh, well, in any other context that would be a horribly creepy thing to hear, but in the context of Twitch and chat, that's really kind, actually. I appreciate that a lot. You love my streams? Well, honestly, that's really kind of both of you to say. I'm really glad that I can be entertaining to some viewers. So, and I want to be totally clear. I'm not planning to stop streaming. I really, life is a game of balance in a lot of cases, right? So, it's not that I'm gonna stop streaming. It's that sometimes I need to take time away from the screen, right? So. That's what happened, and what's happening now is I'm getting right back into it. So here I am, and I'm glad to be here. That I truly mean that, and I'm glad that you're here too. Yeah. Okay. Let me see. Yeah, one one little problem from stopping for a period of time is I almost like forget how to do it. It's like, oh yeah, how did I sit for 2 hours at a time and just talk and work and all that stuff? I gotta think about it again. Do I know Michael Reeves? No. I wanted to say the name sounds familiar, but is that a YouTuber? Oh yeah, okay. It turns out I do know Michael Reeves. His content is it's just in its own category entirely. Yeah, yeah. So I actually have seen some of his stuff. I believe he like works with iDubbbz from time to time, right? I think that's where I first saw him, and I've seen a few of his videos here and there. Do you enjoy Michael Reeves' content? Just out of curiosity. He does a lot of like wacky engineering and building and stuff like that, if I remember correctly. Okay. Let me see. See, this is what I do when I don't know what to do next. I just start moving I just start moving the window panes around a little bit. Because that's totally a useful thing to do. Oh boy. Hey, it's fine. You know what? I just gotta find that groove again and get right back into it. So I do have here, may as well talk about this setup here for a minute. It's not that different, but what I've been doing now. So before my break, basically what I was working on were these two things, this stylo library, and I was using ASDF as like a scratch window, and I was using this to compile Clojure script and produce little sample web pages here, right? And that's all fine and good, but I actually thought about it. So one thing I did do while on the break was spend a lot of time just thinking about how I wanted to approach things. And I wrote, like, I'm not going to show this whole thing, but like I just write little scratch notes to myself about ideas and things like that. And one thing that became pretty clear is a bit of a separation of the libraries that I'm writing. That'll actually, I think, be really quite helpful. So basically it's like this. Forge is the 3D data model / building lib library. So what that means is this is the data model library that will produce all of the 3D models that I'm going to be working with. Stylo is a document rendering library using HTML, SVG, and other web-based rendering APIs as necessary. But the stylo library is not a server tool, just a CLI. Well, let's not overcomplicate it. So stylo is totally just responsible for taking data, transforming it into basically HTML and SVG, and that's pretty much it. So this is, you can use Forge and stylo to create without a server at all. You could just use your command line, basically. This is the idea, to create 3D models. They're not going to be, interactive necessarily. They're not really going to be dynamic, but you could write a script that produces valid Forge models, run that through stylo, and then you can have a document that's produced. That's the idea there. And then ASDF, name to be determined, is a component library for interactive pieces. Example, sliders, inputs, buttons, mouse and keyboard inputs, basically using functional reactive style programming to make apps. So the whole idea here is, as needed, you know, if I need to make a quick design for a client but they don't need a web page for it, I make a new project, I pull in Forge and Stylo as a dependency, I code up the logic, and you can run that on the command line and it'll produce some output for you. If I need to make some interactive mini app for someone, again, you pull in Forge, Stylo, and ASDF, and you can use the things from all three of those to build up a structure of an app that you can use to make more advanced interactive tools. So that's the whole thrust of what I've figured out would make sense as a set of libraries. And each library is useful in isolation. You don't need to do the 3D modeling stuff to be able to make decent documentation of something directly with Stylo, because it's got SVG wrappers and it's got HTML and Markdown processing stuff built right in. So you could use this to make documentation on your own without pulling in any other libraries. Likewise, if you just want, if you theoretically wanted to use the data model that Forge has, but you wanted some output method that I haven't programmed, you wanted to, let's say, render it to directly to GLSL, like a shader language, to output functional or like implicit functional representation 3D models directly onto a GPU or something. You could pull in Forge, use its data model, right? You could build up some data structure to represent a 3D model with just Forge, and then pipe it into your own program at that point. Likewise, you could theoretically make an app with the components in ASDF without either of these. Now this one is so my comfort zone, kind of the most straightforward thing is actually this, in my opinion. It's basically just, right, you just have I think I've got, boy, now I gotta remember what it's been a while since I poked through, but basically Stylo is easy. There we go. I think that should work. This is HTML stuff. I think no hiccup in there. Did I not pull in hiccup as a dependency? I did. There. Well, okay. Anyway, point is, Stylo is where my comfort is right now. Forge, I'm reasonably comfortable because it's Clojure data and higher order functions and stuff, and that's exciting to use, so it's really fun to work through those problems. So that feels really exciting. But I have very hey Mike, how's it going? How are the travels? They were really good. I successfully and safely traveled to and from the States without any without feeling sick or anything like that, and all is well. And it was so worth it for me to see these friends of mine that I haven't seen in a few years. Actually, it's been quite a while, so it was very, very fun. Totally worth it. So in Glad to hear it went well and I stayed safe. Yeah, thanks. I appreciate that. Not sure if everyone knows this. So I live in Canada, and the states in Canada, we're handling as countries the virus concerns quite differently. Well, I don't want to get into a whole thing, but the U.S. and Canada are different governments, and the approach feels different. I'll leave it at that. Point is, when you can fly into the States and you can fly back, but when you land in Canada after having traveled, you are required, technically, to self-isolate for 2 weeks. So for me, that means staying in my apartment. I'm not even supposed to go out and get groceries. I'm not supposed to go out and on walks or anything like that. And it's only 2 weeks, so it's pretty manageable. But it was so, seeing these friends of mine for this time was totally worth the 2 weeks of cabin fever in my little apartment. So yeah, well worth it. I was very happy. It was a good decision on my part, I think, and yeah, totally worth it. All that to say, though, anyone listening now, I think we're in kind of just strange, bizarre times anyway. It's important to stay safe, and I think to make decisions about what you do and how you act that consider the health and well-being of not only yourself but other people, right? So travel responsibly and carefully, and be safe, take care of yourselves, take care of other people. But I'm not here to preach, I'm just here to start programming again. Oh, it's great to be back, honestly. I was a little worried that I would pop back on stream and total dead silence in the comments. No one would come back and tune in again, because it's been a little while, right? And all the stuff you read and hear about when you're starting new YouTube channels or Twitch channels or anything like that is gotta be consistent. You can't stop doing this, can't stop doing that. And well, I mean, I am a human. Sometimes I need breaks, so I was nervous, but yeah, I'm glad there's some people tuned in and talking in the chat. That's fantastic. I appreciate that quite a bit. Okay, where was I? Oh yeah, I was explaining a little bit. Yeah, so I've got a better understanding of a little bit of split between the libraries that I've got here. Forge, 3D data model, Stylo, document rendering, ASDF, a horrible name for a interactive components library. This is, and I was explaining, I'm comfortable with working in the Stylo thing because it's just transforming data into basically HTML files. Forge I'm comfortable with because I'm not totally comfortable with it, but it's really exciting because it's like thinking about math and geometry and stuff, and that's just fun to me. And ASDF is where I'm the least comfortable because it's actually the nuts and bolts of producing a visual app that people can interact with. That's kind of the idea. That's what I mean by interactive components. It's the code that lets you drag and drop different things. It's the code that lets you save a thing and all that kind of stuff. So this is new territory for me. So I expect that over the next couple of streams and weeks and so on, Forge and Stylo will be more and more clear, and just be able to chunk away at the tasks to making them really nice and complete. And the component library is going to be kind of a sticking point. It's where I'm going to have to learn a lot of new things, step out of my comfort zone. So that's going to be an exciting challenge. I'm excited about that. But that's enough chit chat without typing. So let me show actually what this data model thing is that I'm talking about. So this forge.proto just means prototype. I have this notion of operations and primitives. Primitives are things like a vertex, a line, a triangle, and a polygon. That's what I've worked on so far. Operations are things like union, difference, that sort of thing. So I've got union, difference, intersection, and whatnot. And one of the cooler ones, one of the more complicated operations, well, so we've got transformations. So far I only have a translate in there. Got to work on that. I also have extrusion, and this extrusion is kind of the cool thing in my opinion, because extrusion lets you, it basically adds dimension to a two-dimensional object that you have. So if I have a list of points that create a 2D polygon, and then I run an extrude on it, you basically pull the shape into the third dimension. And that is extremely powerful when coupled with 3D unions and differences and things like that. You can make all kinds of phenomenal shapes. So I've got a little bit of what am I trying to say? I've got enough stuff here that I can extrude flat edge polygons, which is quite nice. And I've got a basic SVG render of it over here. So, but first let me go and make a data structure example here. Let's define A to be a polygon. Actually, no, let's do this. Define A to be the extrude operation of the shape polygon, and the polygon I'm going to define as regular polygon points. Hey Biz, how's it going? Glad to see you here in chat. Hope you're doing well. Regular polygon points, it's going to just give a radius of 10 with let's say 6 edges. So this function here just creates a list of points in 2D. You doing well? You're straight? Nice. Glad to hear it. Glad to hear it. Back in Canada? Yeah, do you mean you're back in Canada? Because I unless it's in the course of a month you've traveled again. Yeah, I'm back in Canada now again. I actually, you were mentioning a while ago that you did the self-isolation. Yeah, you're back, yeah. I had to do the 2 weeks of locking yourself in the apartment as well, and man, oh man, turns you loopy by the end. But I made it through, no problem. Let me see here. Yeah, so the polygon function takes a list of points and then produces it basically connects the dots. Regular polygon points just makes a hexagon in this case, 6-sided thing. If it were 8 sides, it'd be an octagon, on and on. And extrude, you need to give it some height to extrude. I'm going to do 25. Okay, so that is A. So if I just print A into here, we've got a big old mess of gobbledygook here. And so what this is the data structure I'm working on. How's Clojure coming along? Oh, it's coming along nice and smooth, in my opinion. I'm having a pretty good time with it. I was explaining how I've got a clearer separation of different library functions in my mind. Forge here is where I'm gonna have any updates in technique. Not yet. It's how am I gonna say it? I want to get to some visual prototype, and I will be using spec on the kind of the what's it called, the on the boundaries, right? On the boundaries of important functions. So it'll be basically here I'm separating. So I guess it's a new technique. I'm making a clearer separation of ideas into 2 different libraries here. Forge is the 3D data model, and that's it. Stylo is the document rendering library, and that's it. And then ASDF is a temporary name, and it's going to be the interactive app components library, and that's it. So I don't know if you want to call that an update in technique, but I have a clearer sort of idea of the lanes a little bit. Idea obviously is if you don't want to make an interactive app, you don't need the app components library. You can just use your doc rendering and your data model if you want to do it directly. But the idea of these separate libraries does nicely also make it makes it a little more concrete where the boundaries are, which is really a great way for me to write good specs, right? So at the boundaries of these libraries, I think it'll be really quite helpful to have these specs, and then I can do what's the word? So unit testing is obviously something to keep working on, but integration testing is kind of the potential idea. I have to learn how to really do that nicely so that the libraries, when you use them together, kind of mesh really nicely and give you a good degree of confidence that you're working on it properly. So that's the idea. My ability to execute perfectly on that is, it's a work in progress, right? But I'm not here to be perfect. I'm here to learn how to get better, right? So that's my ideas. And one thing I'm quite excited about is this sort of data structure that I'm working on here. The 3D models I'm gonna basically just have as maps. The nice thing about a map is you can put it into an atom if you want to make it mutable. You can pass it into a React app environment, and you can make the 3D model map the state of the app itself. So there's a lot of power that you get when you put things into a map. It's also the case that there's a lot of really clever map data manipulation and testing libraries that people have made in Clojure. So it's just a really good data structure to use. And it's all a little experimental, but the whole idea here is I have some functions that build up the data and put them into the proper spots of a map, and whatever operations you do from the Forge library, you're guaranteed to get this map structure as the output. Then you can take that map structure and run it through whatever kind of renderer you want. So someone could, if they want to completely forget if they don't want to use my SVG rendering at all, they don't like it, they think it's a silly way to do it, and I haven't written a nice 3D renderer yet for whatever use case they have, it's totally possible to use Forge to spit out these maps, and then you can just write, you can write something that reads that, because it's just going to be data, and then renders it however you want. You could even post-process it. You could do further work. You could make it. You could compile it or transpile it to some other language if you wanted. The idea is it tries not to make too many important decisions on anyone's behalf. It's like, here's the data. You can do what you want with it. At the same time, it's a map with useful data right in there. So the history is really simple at this stage. It's just a list of function calls with the arguments that you passed to it. So here, I defined A as an extrusion of this polygon. So if you look through the history, in fact, let me make it just a little bit easier on us here. If I pull the history key from from A, right? It's still hard to read because it's a lot of data, but if you look here, it's a list, right? It's a vector, and the first call here is polygon, right? And polygon was called with this list of points, which is true. If we go back up to how I defined it, I called polygon with this function, which is not part of the history. It's just, it was reified directly into a list of points. So it was evaluated. So you see in the history, polygon called with these points. The second thing I did was extrude that set of polygons, and so you see correctly, you see the extrude right here. So if everything else in this map were deleted, I could still reproduce the exact shape by just running eval on the sequence of things here. In fact, the way this is written, I don't even need, I only need the last thing, right? So the history, and this is where things are still prototypes, right? Because I might have overdone it with the history, right? It might explode in terms of storage size, but it's basically recreating the function calls, and here, like, it's even nested, right? Like, I could just, if I just pull last object from the history list, I'll be able to right away reproduce the whole thing. And I'm going to keep explaining the data structure, but I actually am going to go to the washroom first for a minute. So hang tight. I'll be right back. It won't be long. I promise I will be back very shortly. Feel free to talk amongst yourselves. All right, back at it. Anyone tuned in now, maybe someone might not have heard this earlier, but I said it at the beginning. They've been testing in my building here the fire alarm system. So it might, it's been quiet for a little while now, but there's unfortunate potential that it does go off. If that's the case, I will do my best to mute the stream. They're only doing it intermittently, so it might be fine, but I might have to stop the stream if it's continuous. It might also be done for the day. I don't know. So just a bit of a heads up that that's a bit of a rankle, a little bit of a wrinkle, but we'll work with it. Okay. Let me see here. Where was I? Oh, yes. If I actually just do, if I pull keys, at least they aren't running fire drills. It wouldn't be very good for social distancing. No, that's a good point. They are, they're doing it kind of the easy way, which is quite good. I think it's smart. They do it during the day because the assumption is, even now, the average person is probably going to be out or at work or something like that. So there would be fewer people in the building anyway. But for someone like myself, I'm working, like my home is my office sort of thing. So, you know, that's just something to have to deal with. But you're totally right. There's no social distancing problems. There's just piercing noises. No reason to really complain. It's important to test the equipment. But fair warning, right? It's, you know, reality intrudes on my desire to make a nice stream sometimes. Right, so the full set of keys here. History, which I just described, is basically you append the latest call to the list of history calls. And since you're building up the object by passing the object through transformations, you'll always be able to append the history. The one thing I don't know how to handle yet is if that will explode, like it'll compound the total storage size of the object. So maybe that becomes an issue in the future, in which case I'll figure something out. The next thing is really cool. It's frep. Frep. I pronounce it f-rep like that, frep. And what frep is functional representation. And that is a whole interesting topic, which maybe I can get into in a little bit. Vertices is nice and straightforward. If I take the vertices of A, it's a list of all of the points that make up the shape. One thing that I haven't handled yet, and this is gonna be a hard thing for me, is double and floating point values and doing math and doing precise checks on those sorts of things. This is always a big deal with CAD systems because you're kind of fighting the need in real manufacturing. You need precision, right? Like you might be talking, okay, that, you know, we want to bore a hole to the 100th of a millimeter because the fit between these two, the shaft and the bore here, are really important to have a tight fit. And if you need to do mathematics on the CAD side of things for simulations or whatnot around those precise measurements, you run into floating point related things all the time. That's also true with checking for things around 0, right? Like this value here, e to the negative 15, I would call that 0, right? Like it's obviously related to this point here, right? So this is negative 10, some really, really small number on the y value, and 0. This one is 10, exactly 0, and 25, right? So you could look at these numbers as a human and probably say, oh, I would imagine that if I were to write this on paper, I'd write negative 10, 0, 0, right? So that, you know, that's going to be an important thing to get right, because things can really get you if you need to work with those floating points. But vertices is very straightforward. Keys of A. frep I'll get to in a moment. Vertices. Curves here is now an interesting one. Okay, here what we have is kind of a really cool thing that I love about Clojure, and other functional programming languages do this as well. You can pass functions around as bits of data, right? So this list of curves that make up the shape that is A, the object A, is a list of functions, right? So this function is a boundary rep line. So if I take first of curves of A, I have that one function. And if I run that function with the correct value, I get some result. Now, frep, I mentioned before, we've got functional rep. And these lists of curves here use a function called brep line. And brep stands for boundary rep. So we've got two, the details of these, they would probably merit their own like YouTube videos in their entirety, which maybe I should do at some point. But they're two different approaches to modeling geometries. And they both have their pros and cons, and they both have some things that make them really easy to work with and some things that make them hard to work with. But my data model here has some functions that you can build up this data, and it basically, the whole idea is you've got a structure that just gives you both a boundary representation and a functional representation all at once. So you can pick and choose downstream from the Forge library what to do with your data. You can use the frep, you can use the brep, you can use both, or you can use just the vertices, which is just a list of points, right? Like you can, the whole idea is you have choice. The cool thing about boundary representation is it works with parametric functions. So this curve, I happen to know, is a straight line. The first curve of A is a straight line. So it's parametric in a single metric called t. So if I pass 1, it goes from 0 to 1. If I pass it 1, it gives me the last point along that line. So I might be able to visually explain this over here in just a moment, but a boundary representation function takes in, if it's a curve, it takes in one variable between 0 and 1 in most cases, does a computation, and returns to you a single point. So in this case, it gives you the point in 3D space of a line. If you have a boundary representation surface, let me do first surfaces of A, and I'll do 0. There's an error because a parametric surface is parametric in two variables. So a curve is parametric in one variable. It's basically the percent distance between the start and end of the curve. And a parametric surface, it has a curve this way and a curve this way in parameter space. So it's two-dimensional instead of one-dimensional. I'm not doing the best job explaining all of this, and maybe in a minute I can just show bits of this visually to make it a little bit easier. But the reason this errors out is because I need to pass not only one variable but two. But it will also return to me a point in space. But I can vary this along there, right? So I get a different point returned. So that is basically the data structure here. The surfaces is a list of surface functions. Curves is a list of curve functions. Vertices, a list of vertices. And frep is now, oh, and volumes is also, it's a list of volume functions, which I haven't tested anything about volumes yet, so I'm not willing to, or I can't speak on it with any confidence about the idea of parametric volumes yet, but it can be a useful thing for rendering out the 3D volume. Now, functional representation is pretty cool as well, in my opinion. The functional representation of A is just a single function, and this function returns a scalar value. It returns a distance. So a functional representation, you have to pass into the function a point in space. Not just a parameter, you have to pass it a point in XYZ coordinate space. And then what it'll return to you is a scalar value. In this case, it's a really, really small negative number. But if I do something like this, it gives me a positive number. And so what this means is it's giving you the distance from the point you put in to the surface of that particular shape. So using that, you can make, basically you can make a ray tracer or a ray march algorithm that basically you pass a ray through the object. As soon as it has a distance value of 0, you draw the pixel, and then you can see the 3D shape. Sometimes these are called signed distance values. In fact, let me, for the fun of it, show you shader toy, SDF functions. It's this functional representation uses the same kind of mathematical ideas as Inigo Quies here has written a lot of interesting articles and code examples about rendering these kinds of functions, and so there's a lot I learned from this sort of thing. So let me see, perhaps there's a distance fields tag. Let's see. Yeah, so this is a really great example. Shader toy can kind of chug along sometimes. It's not necessarily the most friendly thing you can be running, but it is very neat. So all of these 3D objects here are using what's essentially the same idea as this functional representation thing here. So these all, these all happen to run on the GPU, which is really cool. But my thing here, it just runs in whatever context you can evaluate it in. So for the time being, it's not running on the GPU. It's just running on my CPU in my process. So yeah, so that's very high level what functional representation is. Basically, you can use the distance value you get to determine how close or far away you are from the object, and you can use that plus some good camera rendering and all that to figure out where the object is. And all of that is really quite useful, but it's also very different than boundary representation. So one example of how things the benefits and difficulties of the different things. Let's imagine you just have a cube and you want to select the exact midpoint of one of the edges of the cube. If you only have the functional representation of it, you have to know beforehand the size of the cube, or else you have to kind of guess, because all you can pass into an frep function is a 3D point, right? So you'd have to, you'd kind of have to voxelize the space and do a bunch of tests, and it'd be kind of hard to figure out the exact midpoint of an edge. However, it's very trivial to do if I take first of curves of A, right? I happen to know that it's a straight edge. If I take that function and I know that all of the parameters run only from 0 to 1, I can just pass in the parameter 0.5, and now I have an exact value for the midpoint of that particular curve. So the boundary representation is almost trivial to figure out midpoints. But in other cases, if you want to very quickly render an extrusion of a complex shape, the functional representation for extrude is rather straightforward mathematically. It's just, yeah, sorry, I need to go here to extrusion here. This extrusion, right, takes a function, an frep function and a height, and it produces a function that just does very simple, you add the it's just very simple math. I don't actually want to explain the details of it right now, but it's very straightforward. However, if I need to do an extrusion on a boundary representation, I have a whole lot to consider. I have to consider the addition of vertices. I need to, where did it go here? See here, for example, I have to extrude, I have to add an entire new set of vertices. For each of the new set of vertices, I have to add new curves. I have to add a new set of surfaces. And that enclosed area creates an entirely new volume. So, you know, frep is often really easy to make compound shapes with, but really kind of difficult to find points that are of interest in the shape. But the opposite is true for boundary rep. So really being able to mix both in as a data structure is very compelling to me. That's a lot of theoretical jibber jabber. I hope anyone listening, if you have questions, please feel free. I know it's not the best explanation. I'm going a little off the cuff here. But if you have questions, please go ahead and I'll see if I can help explain it more clearly. But what's really neat is that set of operations I was able to pull into this app, this ASDF scratch area here. And I actually have, let me close this now. I don't need this as much, so let's shrink that down a bit. Right, so if I go here, Proto 3D, I've set this up. Let me give this a proper name. Test shape. This test shape is the extrusion of a polygon of regular polygon points. This is basically the same thing I showed in the REPL here. This here, oh, it's going to error out because I didn't change the name. Yeah, ASDF doesn't exist. Test shape. Save that. There we go. So this test shape here is that map full of different structure types. And what I've done to render this is kind of, in my opinion, pretty neat. I've actually just run it through a for comprehension here. For every edge in the list of curves of test shape, do these things. This here, SVG 3D, just transforms it to the isometric view here. And for each of those, draw a line from the edge at 0 parameter and the edge at 1 parameter. Right, so if I were to change this parameter to 0.5, right, every single edge is going to draw only to half its distance here, right? It's only half as long. Now I have this line across here is a bit of a render glitch, but that's related to, or it's not a render glitch, sorry. That comes along because of how I'm adding the curve functions into the thing. So I have a curve function for every single edge, but I also have a single curve function for the complete polygon shape. So there's a bit of doubling up there, and I have to maybe figure that one out. But point is, you can adjust how you render out these lines, which is, I think, just pretty cool. And you can see, right, so like I have said here, this, if let's make a line there from edge 0 to edge 1, but now let's also, how can I add, I also want to add a circle, like a dot at the midpoint of the line. So let's see if I can come up with a way to do that efficiently. Just thinking for a moment. Right, if I go here, what does stylo draw a line? Forget the shape of the data for this thing. Oh, I did something wrong, but that's okay. I hope people are able to follow what I'm talking about a little bit anyway. I know it's a little confusing. I haven't like practiced a thorough explanation yet, so things are still a little loosey-goosey. Right, so I should be able to do this by SVG group this line with SVG / translate to the position edge 0.5, which is going to be a point in 3D space, right? The SVG / circle with a radius of 1. I think that should work. If I do SVG / color pink. Let's see if this is going to work the way I want it to. It does not. Okay. Successfully compiled. Okay. This is coming about in part because I haven't built a proper render function yet. I'm just using these sort of slapdash functions, so it's not perfect for what I'm trying to illustrate. Let me instead let me do this. I'm going to not there. I'm going to remove that, and I want to need to take one of those away. Is this going to work? Wrong. I goofed somewhere. Oops. Well, okay, let's do it this way. Yeah, this is not the smoothest setup. 4G scale color drawing figure that thing, close the function. Is this gonna work? Let's see. Wrong number of arguments. Okay, I goofed somewhere. Okay, all right, what's going on here? Here it is. This line is supposed to be in the group. Okay, now see if this is going to render properly if I refresh it. Okay, there we go. So this circle size is a little too big here. So what I did, I removed the transform to the isometric view because I haven't built those functions to properly do it for anything other than edges or lines, so it just isn't working yet. So the reason, okay, so this is a little confusing. All I've done was make this circle at midpoints for every edge. The reason you see the circles at the corners here is because this is a 3D object and we're looking straight down it. So the this is actually displaying as the midpoint of the vertical line there. So it looks wrong, but it isn't. Yeah. So it's also true that the axes are now incorrect because they're not translated. They're translated to the isometric view. So this is what I mean. The SVG rendering approach I have is very slapdash. It's not. It should really bake into one single thing, sort of a scene and a camera, which is what everything does basically. So what I should do instead, or what I can do instead, is kind of what I've done over here, where oh boy, animate, I made the whole thing, eh? Right, so this is obviously, I'm even confusing myself thinking about this. Not exactly helpful, but to step back again for a moment, let me undo some of these changes here. Here, get rid of the circle thing. If I go into for this, let's fix all these. Another thing, there's a lot of things I still haven't fixed because when you're stuck quarantined for a while, you think you get a lot of work done, but you end up being lazier than you anticipated. It's not an excuse, it's just what happened to me. So instead here, let me do draw/orient ISO. Draw/SVG 3D to SVG is the function I actually meant to do. This should get me back to a, there we go, okay. Now actually, while I'm here thinking about this, right, if I make this 8, it should be an 8-sided thing. Yep, this can go to 4, so I can make a box on the diagonal, which is pretty cool. Pentagon. See, that's pretty nice. I think that's really cool, and I can extrude it to other directions here. So a negative extrude, instead of pulling up along Z, it goes down. Very cool that it's working. One thing I did here, I'm gonna stop rendering this, so it'll show nothing. It might even error out. Nope. I'm gonna pull this back in, and this won't work because this is not the right thing. This now is how, gotta refresh it. Here, this is a set of points that I'm rendering along the surface function, right? So what I've got here, I've got U and V as the parameters going from 0 to 1, and I have different spacing for them. Let me make them both 0.5 to make it a little more sparse. There we go. And here, I'm just drawing circles on every single point that is produced by running this for loop here. So, and I've taken the first surface here. So if I take the second surface, it'll look different. No, I guess it doesn't. Nth surface, let's take the 0, 1, the second, or the third. Here we have, it's a 3D surface and it's a square surface, so you're only seeing the top edge of it, but they're all rendering, so that's working, kinda. Let me see for a moment here if I can figure out how to render that in a nice isometric approach here. So this function here, SVG 3D to 3D of a line. Oh yes, so I've been working, okay, this is a def method. Let me see if I can, for a moment, do it with, wait, I have to think about this for a second. Okay, so what I've done here, let me see, source stylo draw.cljc. Will this load fine? Yes, it does. Okay. Good, good, good. I lost my train of thought. Right, okay. So this here, okay, what I was doing before was doubling. So if I do SVG, well, let's load file source stylo svg.cljc. If I do stylo slash, is line even a function there? It is. So line takes a 2D point and a 2D point here, right? Oop. And it produces this structure. It's a vector that has a keyword line and a map of the properties x1, y1, x2, y2. In the draw area, in the draw namespace, I've created a function line that produces an equivalent result but uses 3D. Now this, I think, is no longer a good idea. I think what I should do instead is produce in the Forge library set of utility functions. I should finish out making the translate and the rotate and scale and skew and matrix transformation functions that you can pull in, and when you come here I can make one single render function that takes a scene, a camera, and an object or set of objects, and just writes SVG directly. So instead of having this sort of intermediate data structure here, which is kind of fake SVG, it's so that's do I even know what I'm saying? A little bit. I've kind of, this SVG 3D thing here, for a while I was thinking it would make sense to kind of create 3D equivalents of all the SVG functions, but I'm not sure that that's actually a good idea, is basically what it is. Instead, what I think I want to do is make some sort of translational code that uses the SVG functions to render isometric 3D models from the Forge thing. So that's going to have to change. But for the sake of rendering out a few things nicely, I can just use orient iso directly on a list of points, I believe. Yeah, so maybe that's what I can do here. So for this surface, you translate this. Okay, this is what I can do. Yeah, I'll do it out here. Let me do test surface. Here, I'm going to do this whole thing. Well, let's just do it directly. Okay, test surface, I'm just going to make it be a list of points. So for u range 0 to 1 with a step size of 0.5 for simplicity, and v range 0 to 1, step size of 0.5 again. That should be fine. For those two things, let S be the surface, and yeah, surfaces of test shape, the third surface, that's the surface function, and all I'm going to do is return the points for all of those UV values. So it's just going to be SUV. So that's the test surface. And what I can do now, actually one more thing I can do. Here, I'm going to do d-orient iso this list. So these should be already transformed into the 2D projection that makes it look like it's oriented as an isometric which is what I'm going for, which means here I should be able to color the points blue, give the scale 10, and group them. And here, instead of this for setup, I can just do for point in test surface don't even need the let statement anymore. Translate a circle translate to the point this circle. There we go. Okay, that is the function. That's the for loop there. I think that should work the way I want it to. We'll find out in just a moment. Yes, it does indeed. Okay, that is good news. So now we can just swap this number out for all of the different surfaces. So there's the top. It's either the top or bottom surface. Doesn't matter. It was the top. Yeah, okay, cool. 20. Oop, gotta zoom out. Yes. Okay, so right, so we've got now the surface, the 0th surface, the first surface, the 1, 2. This will be a rectangle. This will also be a rectangle. This should be a rectangle. Right, I'm just going around the shape. Now this is a cool one because it's the union of all of the faces. So see here, this is where I need to get a lot smarter about how I end up rendering these things, because right now I just need to render a whole bunch of points, which is going to be very slow, right? Because this is now so many SVG circle objects in there. It's not efficient. It's not exactly a smart approach. So it like this will not scale well to many objects, right? But I can create non-uniform grids. So, you know, in the vertical dimension here, I only need, let's say I only need 10 samples to see exactly what it looks like, right? So there's a lot of, there's still quite a bit of control I have. It just isn't necessarily the most efficient. Are there 9 surfaces on this? Count surfaces of a 9 and okay, so this should have been an error. Why did this work? Maybe it didn't work. Okay, so we're in the money there. So now that I'm here testing a surface, I do wonder what happens when I do. This is untested. I don't know if this even makes conceptual sense, but what I'm going to do here is volumes of A is just a single function. So nth of volumes of the test shape should be 0, but it should have a u via w. Let's see what this looks like. It doesn't look like it's anything that makes sense. Well, let's run this in here then for a minute. Okay, so if I do first of volumes of A. That's a function. If I run this function on 0, 0, 0, does it give me something? It does. Okay, so this function doesn't work. It doesn't make any sense. This function is broken, which is fine because I haven't really thought it through yet. So okay, so that's good to know that this doesn't actually make any sense. Let me just double check that it doesn't work on 2 arguments or on 1 argument. So it at least is looking for the right number, u, v, and w. But this doesn't return valid stuff. So one thing that I think I need to figure out a smarter way to do is union triangular or union surfaces together for arbitrary polygons. What I have here is something that does work. As you approach an infinite number of parameter points, it does create the surface that you would expect. See how slow this is? Uh-oh. Okay. As you approach an infinite number, right, between 0 and 1 of samples of the parameter space, it looks like the surface. But 0.05, 0.05. It's not a very smoothly continuous set of points. You can see the shape of the triangles that I used to produce this shape. So all I did was, for any polygon which is currently just a list of points, you can triangulate a mesh over those points in 2 dimensions. Each of those triangles you can turn into a surface, and then you can union those surfaces together to create a single parametric surface. But for each triangle, you can have a discontinuity sort of between, like where your point will jump to some new spot. It doesn't necessarily make sense spatially to build up the triangles in that way. So it works, but it's not the smoothest. So that's something I don't know a solution to yet. There's probably better meshing algorithms that I could use, or I could maybe do it in a quad-based sort of approach, or I could do some sort of surface subdividing, and then each of those subdivided surfaces I can union, so I have a smoother sort of thing overall. I have to figure it out. But it does work, which is really cool. I'm wondering if there's one final thing that would be useful for me to do. Because I think as a first stream back, I did a pretty decent job. I'm pretty happy with how things went. It was nice to have a bit of viewer engagement for a while. But I don't know what I could do effectively in a shortish amount of time. It's already 3 o'clock. Probably I'm gonna get some water, clear my throat, and then I'll be back in just a minute, and I'll see maybe if something comes to mind to be able to do a little more effectively. Whoops, wrong spot there. Be back very soon. Let's go ahead and mute this. Okay. This is unrelated to my programming question. If there's anyone viewing right now and you're interested in helping me out just for a second, I'm curious if you could try just run a command in the chat. It's not important. Never mind. It should be fine. Yeah. That'll be something I can worry about later. Okay. Let me see. What would be neat to do? So there's one interesting thing, right? If I do, if I run a function over, okay, let me do this. If I map for every surface function a call at 0, 0, yeah, that should be fine. If I map that a call at 0, 0 over all of the surfaces of A, right, I get all of the starting points of every surface. And if I do the same thing at 1, 1, I get all the end points. Oops, that's not what I meant to do. I just meant to run this. Right, these are different point sets. Actually, let me see what happens if I just do this. Okay, so for U and V has a range, instead of 0 and 1, I'm going to just explicitly call, for this surface, I want to see the starting point, the middle point, and the end point of the parameter space. So I want to see what those are like. The reason I'm trying to do this is because I have to start thinking about how I can render faces nicely in SVG, because I cannot, I say faces, I should say surfaces, because I can't efficiently use these, like this dot method, to render every single surface. What I want to do is, for a face like this that is some transformed polygon, I want to be able to use an SVG path element so that I can apply colors to the faces and I can click the faces and things like that. But right here I can't, because it's just thousands and thousands of circles. I want a single path object to represent that particular curved face. So what I'm trying to think about is how I can identify all of the exact corner points of a surface easily. And you can do that for things like squares relatively easily, because it should be, well, I don't know. I'm going to explore the mapping of things is really what I'm trying to get at here. So U and V00, U and V, U1 V0. Okay, so 0, 0 is here, U1 V0 is here, 1, 1 is the next corner, and U0 V1, like that. 0, 0, 1, 0, 1, 1, 0, 1. And now I also want to see what the exact the exact middle points look like. Okay. That should work just fine. Should make very few points, but it should work. Okay, so this is strange to me. What? Why is that the case? It looks like why is that? I don't understand. Okay, I wonder if I have unnecessary point overlap. Okay, so here, right, here is an interesting thing. I have pretty nicely these, let's just make this, instead of extruding at 20, we'll only extrude at 10, just to keep it a little smaller here. This face, it looks conveniently, oh, I know, I can, let me do this here for a minute. Okay, let's make these edges black. Oh man, I have to move some things around. Always a little bit annoying, but that's fine. Yes, so I think this should work for that. Does that work? Yes, okay. Now for this part here, translate to the point, I can do this here, svg/color blue, the circle, and that should work. Oh, they're still black. Why is that? That's confusing to me. They are blue. Oh, okay, okay, I see. Point 1. Does that look nice? Okay, okay, I see. They're behind the line, so it shows it's a little harder to see. Let's move them in front of the line, and that won't be an issue. And we do that just by moving the for loop. That should work. Yeah, okay, there we go. So we've got these points. So what's interesting to me here is this array of points for this particular surface that happens to be a rectangle, right, nicely lets me find the exact corners. So I could use that to draw a path for that surface. The same logic simply does not hold for the polygon, or pardon me, for the hexagon surfaces, right? There's this weird point overlap, and they just don't line up in any intelligible way. That it doesn't make sense. So I can't rely on the implicit corners of particular u and v values to draw a proper surface shape. So I need to figure out something different for rendering surfaces in a nice way. And I don't know exactly how to handle that yet, because I don't necessarily want to tag data in the Forge library, although that might make the most sense to do. Not sure if any of that made sense. Maybe I'll have better explanations tomorrow, but I'm thinking through this right now and I don't have exact solutions yet. Let me let's pare this down to the 0, 0 point and the 1, 1 point. Okay, so if I do this, okay, so that is interesting that those points overlap exactly. And I'm assuming the reason that happens is because of how I implemented surface unions, where at the boundaries there could be overlap, I guess. Is 2 valid? Let's check. Let's take first from surfaces of A and run that with 0, 2, nil. Okay. So nil means it's an invalid parameter. So this just means I have remapped these are all equal. Why is that? Okay, 0, 0 is not equal, but 1, 0, 1, 1, and 0, 1 are all equal. So something's going a little strange at that particular boundary. This is going to need some rework for sure. So what's happening is, I also, okay, this is a different thought for a minute. I have to do this. Oh, that's the wrong, I meant this. Okay, so this is confusing to see. My brain is not picking up this. Let's turn off these lines for a moment. Where am I at here? This is invalid. Oh, wait a second. That's weird. Why are there 3 points on the screen right now? Ah, that's very weird. Okay, 0, 0. Okay, what I'm doing here is just seeing I'm just exploring the implementation I have for like the implications of how I did the surface unions of triangles. This top shape, oh, that's way too it's way too many. Let's also move it to the bottom. Let's make this 05, 05. That should be a little more visible. Yeah, so you see here I've got two triangles making up this square shape, which is different than the surface if I do 2, this should be the front face here. Yeah. So the points are nicely distributed here, right? From when you range it 0 to 1, 0 to 1, it makes a nice simple grid here, which you would think would be how it's done for this top face. But the reason these are different is because the implementation of these particular surfaces are different. Now, in both cases, when you bring your step size way down for your parameter values, they both in the limit will approach a true surface. So it mathematically, theoretically doesn't matter, but practically speaking, they render weirdly. This one here it was a line equation, and then I extruded that line along the z-axis, making it a surface with just nice even distribution first along x, y, then along z. Whereas the top face was I gave it a list of points, I triangulated it, and then for each triangle I unioned them together. So that they produce different results. One has a nice grid-like pattern on the points, the other has strange looking overlaps and such. And so that means I should rethink a few things. Right, so if I go over here to operations, if I do brep CSG here, this union is what I'm talking about here, this surface union. So what algorithm I've got here is, so you pass it in any number of surfaces. Let n be the count of the surfaces. Ooh. Let's zoomed in a little more than I wanted, but I guess that'll be fine. Yeah, it's almost time for me to go because my brain is slowing down a little bit and my explanations are not quite as good as they were at the start of the stream. But that is totally okay. I'll just kind of quickly explain this, almost to myself more than anything, and then I'm probably going to get going. So here, this is what I'm talking about though. So let me, before I explain that actually, let's just change this back to some number and have a look at surface 1 instead of 2. So here we go. We've got a really kind of strange hopping around from place to place here. Oh, you might even be able to see the sort of strange path if I do. Yeah, actually, that's kind of a fun idea. Okay. SVG slash path. I think that'll work. It does not. Why is that? Oh, I messed up some. I missed a bracket. Perfect. Okay. Now I just need to do svg/color. Let's do pink because it's fun. Pink because it's fun. Did that work? I'm trying to trace out the order of the points with a line, or with a polygon line. I don't know what I'm talking about. And the reason that is not working is because that's not the right function name. This should be path-polyline. What happened? Why didn't it work? Well, let's have a look here. svg/path polyline. Just do a list of points. Yeah, that should work. Why did it not? I don't know why this isn't showing up. Maybe oh, maybe it's a scale problem? No? Yes? Yes, no, maybe? I don't know. Okay. What's going on? Clearly, one other little problem with taking a bit of a break is you lose a little bit of your thinking power on what happened, right? Like you end up a little bit lost from where you were before. Now, I thought that this was all sorted out, but it's possible that svg/color doesn't work on everything yet because maybe I didn't implement it all. It's possible. Right, so if I do style, okay, color element is not a multi-method, so it should work on anything. It should work. Let's see why it isn't working. Let's inspect this element for a moment. SVG, group. There should be a path somewhere in here. Path. Okay. Running out of screen real estate here. Uh-oh. There we go. Yes, it is a scale problem. I was reasonably sure. Okay, this is what it is. This group does not contain this color. I want it to contain this color. I'm surprised that it, no, is that it? It does contain it. What's the deal? Oh, there's something. I mean, that looks really cool, but that's really not what I want. It's not at all what I need. Huh. Okay, what's happening here? Something doesn't make sense to me. I don't know what's going on. Disappears. Okay, I have a hunch that it's related to different functions overriding scales and translates and stuff like that when it shouldn't. Okay, so the idea here was, I'll explore this later. This is wasting my time at the moment and confusing me for no real benefit. Let's just have a quick peek at this surface union and get going after that. Okay, so this surface union here takes any number of surfaces. What you do is you count the surfaces and your intervals become determined by the total range of like determined by the number of surfaces. So your first interval is from 0 to 1 for the first surface. Your next interval is from 1 to 2 for your next surface, and then 2 to 3, and so on and so on. Then you return a function uv, which will create partial surface functions for the value that already have the value you baked in, and then you apply a curve union to the surfaces and then run v through that. This is very confusing, and basically what it boils down to is I'm passing in right here for a polygon, I'm passing into that function, that's the functional representation version here, brep surface polygon. I'm passing into the union, the surface union, a whole bunch of triangles, and I'm mapping each triangle there. So what happens is you have you basically just have a bunch of parameter spaces in U to V butted up against each other, and the V parameter is always from 0 to 1, but U extends and extends and extends and then gets smushed back down. The other thing is, since it's a triangle, U and V don't map in a nice grid fashion onto that. All of the points smush together at one of the corners and then kind of spread out further down. And the orientation of the triangles isn't necessarily important. It's all this needs a bit of rework, but it's a big step in the right direction, and I'm really happy about that. So I've been kind of yammering today. It's my first stream back after a little bit of a break. I am extremely excited and happy to be back streaming again. I've been going for a little over 2 hours now. I think it's a good time for me to stop for the day, but I should be back again tomorrow. I think I'm gonna do my streams a little bit later now, so I really hope a lot of the same audience can still tune in for a little bit, but I also hope that maybe I can get a little bit of new audience in as well. If I do streams a little later, I can get maybe some people who come in after work, that kind of thing, in North America as well. So my stream schedule, basically I'm thinking I still want to do Monday, Tuesday, Thursday, Friday, probably starting around 2 o'clock, going till 5 o'clock, maybe starting at 3, going to 6 kind of thing. I have to see, and I have to maybe even experiment with doing streams in the evening. So I don't know how I feel about that entirely yet. I'll see, but the simple thing is I'm not stopping streaming. I'm going to keep it up. I use it to be productive with my code, and it's really fun to share and talk about design ideas and stuff like that. So thanks for tuning in. If you're tuned into this live, I appreciate that. If you engaged in chat, thank you so much. That's always really helpful, really encouraging, and it's fun to engage. No one should hesitate to leave comments on YouTube, leave chat messages if you're watching live. There's ways you can support. One, you can share this Twitch channel and the VODs channel in programming environments. Share it with people who you might think would find it interesting. Please, please, please share it around. Follow, subscribe, all of that stuff is important to me. It's important to kind of get the channel growing and going. Anyone can check out my Patreon. That is very helpful for me support-wise, because I occasionally it runs through my mind to get some nicer equipment, and I need money for that, plain and simple. I can't do this forever. Money will run out at some point. So financial support is always very helpful. So at the moment right now, I can't do it through subscriptions and stuff on Twitch because I'm not yet at that level. So if you want to support me financially right now, Patreon's the way to go. Absolutely, I will open up all the subscription stuff and Twitch stuff at some point. But in order for that to happen, I need to get, I believe it's called affiliate, and then become a partner at some theoretical future point. But I need help to get there too, so share it around, and tune in and watch and engage, and more people will see it and participate, and that'll help me out. So that is my blather at the end. I'm gonna sign out for now, and I'll be back tomorrow. So one last time, thank you for tuning in, thanks for participating, and I will see you around. Have a great day. Goodbye.